Hello and welcome to the video on the properties of chords intercepting each other within a circle. In this video we will look at what happens when two chords intersect and how this can be used as a proof for concyclic points. First, the theorem. That is, the product of the intercepts of chords are equal. This means that if you have two chords that cross, in this case AC and BD, then AX times CX will equal BX times XD. It's an interesting theorem and is proved using similar triangles. Let's look at the proof. First, our aim is to prove that PR times RQ will equal SR times RT. We know that PQ and ST are chords that intersect at R. For our proof, we will join PT and QS and create two triangles. In triangle PTR and triangle SQR, angle PTR equals angle SQR. This is because the angle's in the same segment. Similarly, angle TPR equals angle QSR for the same reason. Therefore, we can say that triangle PTR is similar to triangle SQR because the two triangles are equiangular. We only have to show that two angles are equal for this proof because by default the last two angles will be equal to each other. If two triangles are similar, then the ratio of their matching sides are equal. That is to say that PR divided by RS will equal TR divided by RQ. This is because corresponding sides in similar triangles are in the same proportion. Now, if we cross multiply these fractions, we get PR times RQ equals SR times RT, which is what we wanted to prove in the first place. Let's see how we can use that fact to find a missing length. Example 19 says that AB is a chord of length 8 cm in a circle with center O. CD is the diameter of length 10 cm. AB and CD intersect at E and BE equals 3 cm. Find the length of OE. Take a minute to pause the video and see how far into the working out you can get. Try labeling as many of the lengths as you can from the question and let OE be X. Okay, I'm starting by letting OE equaling X. AB equals 8 cm and BE equals 3 cm from our question. Therefore, AE will equal 8 minus 3, which is 5. I can also say that OD is going to equal 5, because it is a radii and the diameter of CD is 10 cm. This means that CD is 5 plus X, the radius, plus OE. And that last little bit ED is going to be 5 minus X, which is the radius minus OE. Our new theorem says that if I multiply CE and ED together, I should get AE times EB. The reason we write is products of intercepts of intersecting chords are equal. This means that 5 plus X times 5 minus X equals 5 times 3. With a little bit of expanding and noticing that the left-hand side is the difference of two squares, we get 25 minus X squared equals 15. By rearranging the equation so that X squared is positive on one side and the numbers are on the other, we get X squared equals 10. Therefore, X equals the square root of 10. To finish, we answer the question, which is to ask what is the length of OE, and we say that OE equals root 10. We can also use this theorem as a proof for cyclic quadrilaterals or concyclic points. Normally, if we wanted to prove a quadrilateral was cyclic, we would need to prove that the opposite angles were supplementary. But if we have the lengths of the diagonals, we can use the theorem to prove that it's cyclic. Let's say that the diagonals of PTQS are 10 cm each and that they bisect each other, which means cut each other in half. We're going to prove that PTQS is a cyclic quadrilateral. First, let's draw in the diagonals and label each section 5 as they are 10 cm long and they bisect each other. PR times RQ is 5 times 5, so that's 25. And SR times RT is also 5 times 5, which is also 25. Therefore, PR times RQ equals SR times RT, which means that PTQS is a cyclic quadrilateral, because the products of intercepts of intersecting chords are equal. This is useful to keep in the back of your mind if asked to prove that a quadrilateral is cyclic and you don't have the angles that are opposite each other. This result is not included in the course, but is good to keep in mind. The next video will detail the properties of tangents and secants when they are in the same question together. Thanks for watching.